So for this part, we're going to have a little bit of a presentation part, and I'll then try to go over in the detail of actually dealing with ndnSIM. But let's start with just the basic one of the introduction and what it is and how it works. So basically, ndnSIM is nothing more than an NS3-based simulator module. And NS3 itself is a network discrete event simulator. It's written in C++, is quite modular, and has active maintenance, and had released multiple versions, and actually recently was upgraded to the very recent version of C++. So if you like recent versions of C++, this is where you can explore your options. It's open source. And for ndnSIM specifically, again, we do everything in open source. We try to solicit as much of external contribution as possible. So if you have something to contribute to NDN or ndnSIM specifically, please just submit code to us in any way possible, and we'll try to kind of talk to you and accommodate this code. And most importantly, for the ndnSIM, what we're trying to do is actually maintain a parity between the real code base and the simulation code base. With a few tricks, and I don't know whether I have time to talk about how exactly we managed to do that, but effectively, we're trying to use the latest, the actual code base for the ndnCXX NFD. These are our prototype implementations of forwarder and the libraries. And with a few tricks, they are kind of powering forwarding framework inside the simulated environment. So it's kind of an interesting approach that allows to kind of have a parity for the fidelity of the simulation results. And so it's on one hand. On the other hand, it is possible. So I kind of put it in here so you can do the emulation of real implementations with a few caveats. You still have to adjust a few things if you write application, because in real applications you usually have some kind of a GUI interactions or some kind of command line interactions, and those needs to be somehow ported to be automated as part of the evaluations. But in principle, you can take the real code base, especially when it's written against ndnCXX library, and kind of try to emulate it inside ndnSIM. As of right now, we have on GitHub quite a bit of number of forks. We don't really maintain all those forks, so you can look and explore how many people explored ndnSIM in different directions. We have a very active mailing list. I kind of checked the latest data; it was over 500 subscribers. And for the papers that was published using ndnSIM, I think we have over 1,000 papers citing our technical report, and I'm sure that would be more papers somehow not citing or citing the code base, that unfortunately it's not easy to track how many papers do that. And what ndnSIM can do, at least already a little bit highlighted, that it's not really possible to do security-related simulations, because you still have to define what exactly you want to look in those evaluations. But rather, you can run reasonably large-scale experiments in a simple way. So what you can, so basically, as there's a simulation environment, you can set up any topology that you like. You can provide any specific, in deterministic fashion, cross traffic if you need to, or if you want to play without cross traffic, you can do the same. You can adjust any parameters for individual nodes. You can define the mobility of the nodes. If you need to have mobility evaluations for that, you can define caching. And most importantly, you can actually look everything into each individual node. So you can add whatever kind of a tracing that you need. Because it's a simulated environment, you can actually get access to those specific nodes and extract all the information that you want from them. This one usually is not that easy to do in real scenarios, because in those cases you usually just rely on packet traces and some kind of inference from the packet traces. On the other hand, like in the simulated environment, you can do a little bit more in getting the information out of this scenario. And of course, you can analyze. You can still get the packet traces and kind of But again, the one that I will be showing a little bit later, even the packet traces that we collected inside the ndnSIM is on a little bit higher granularity than just packet traces, because they're already separated between the, is it interest, is it data packet, or is it some NDNLP NAC, whether it's sent out, whether it's received, and on which phase it was received. And on top of that, we also kind of have, because in NDN, we don't really distinguish between interfaces to the network, faces to the network interfaces and faces to the application interfaces. So we can get all this information about the packets we can get from the network perspective and from the application perspective. So and getting packets to the application and receiving packets from the application. As for the structure, so this is where the tricks of our implementation are coming from. So we're basically taking the code of NFD, and the NFD is based on ndnSIM, and directly plugging it inside the simulated environment. The way we actually accomplish this trick is by kind of switching the real time, because we kind of in ndnCXX, we have implemented scheduler component, and that scheduler component is being used throughout the NFD code base. And we're simply kind of replacing that scheduled implementation from the real one to the simulated one. And this almost immediately becomes possible to do it in simulated environment instead of dealing with the real time or like the wall clock time. We do everything in simulated time. It comparatively to the initial version that we actually had implemented initially for the ndnSIM before NFD was in existence, it incurs a little bit more overhead and a little bit in a little bit big quotes, like requiring additional memory for the actual node management, additional memory for potentially for the packet processing, but allows this fidelity of a simulated environment, because we run in actual NFD code. We're not reimagining how things are working inside the ndnSIM compared to the real code base. But again, it's not really possible to just take NFD and plug everything in and everything's working, because ndnSIM have a logic how simulation scenarios are run. And for these purposes, we actually created kind of NDN-like applications inside NS3 that working through this specialized phases or app links. Anyway, just basically linkage from the from the NS3 world to NFD world and back. So that's kind of a high-level structure, and I'll probably go a little bit more later into individual components, at least the relevant components that we're going to be talking about. And this is just another highlight of what components of NFD actually ported. Not everything that is available, NFD is available directly inside the NS3 environment, because some of them applies, some of them doesn't apply. So for example, here, there's a little bit about faces that is grayed out, is IP faces, so TCP, UDP, and other type of faces that not over direct links. And just because there's a completely different process how you deal with networking on kind of on a transport, even on the network layer, compared to the standard sockets. And standard sockets is a completely different picture what needs to be done as part of this. But the rest, all the forwarding strategies, all the forwarding pipelines, PAPE, FAPE, content store, there's also some measurement tables, all this available directly. You can also even use the read manager and all the management protocols if you like, though by default it's kind of a little bit bypassing in basic scenarios. But in more complex scenarios, you can actually use those facilities as well. I kind of highlighted that we can use real simulation, real applications in, I wouldn't say like completely real applications, but rather taking a code base of the real applications and trying to apply them inside ndnSIM. And for this one, what we have done is a special hacking of this NDN face. So this is part of ndnCXX library that allows, basically, if you write the application against ndnCXX and using NDN face as part of this application process, to express interest, to publish data, to register prefixes, then everything, all those routines that happen like in real NDN phase would be seamlessly transferred for the NS3 related routines, and everything will be mostly working. There are a few caveats. It may not work directly. It's only a few constructors available in there, but you can make it work. And the example that we're going to be given is actually using these features. And for the ndnSIM, so this one is a little bit interesting. So first of all, I already kind of highlighted that we need some kind of a shim between the actual NS3 routines, because like in NS3, everything happens with events. There's like a special emulation of the links, and on the links there's things that happen, like using net devices. You have to schedule, like you have to register specific callback to receive the packet. You have to call specific method to send the packet. So for that operations, we created like the specialized transports. I mean, transport, and this is term for the NFD, and specialized link service classes that really deal with the just transferring interest in data packets through this net device component of NS3. We also created this NDN app as a kind of basic component to create NDN applications. And this one I will talk a little bit later in the example. And NDN phase I just talked about is for the other type of simulation environments. So the part of how to do the simulation and inside the ndnSIM is a little bit of I wouldn't say shady topic, but it's a bit complex because you can do it in multiple ways. And it really depends on what type of simulation you want to run, because there are simulations that are entirely focused on the networking component. So if you just want to evaluate the forwarding strategy and you don't really want to deal with the logic of the application. So in those cases, you just want to generate traffic, you want to receive packets, you want to basically publish data, but you don't care how those things are happening. You just need to do the publishing. So for those applications, you prefer to use the NDN app. So this is the very basic component for the NS3 for ndnSIM. If you want to have a networking evaluation, but you want to look at the application logic, so this is what kind of looking at the chat application, looking at the transport logic with the NDN SVS. So for those cases, you want to have a little bit more complex application, a little bit more complex scenarios that would rely on this NDN phase. And there is actually yet another helper to create applications, like instances of applications that rely on this NDN phase abstraction. So that's, I will try to talk a little bit more in detail when I go to actual code and show things how it's working. For other components, I already highlighted. So the tables, basically there's nothing special that we, as of right now, we do inside ndnSIM. So the previous versions, we actually had a separate implementation for the content store, because at some point NFD was not yet supporting flexible content store implementation, different policies. But as of right now, everything is supposed to be done inside NFD. So if you really like to play with the content store policies, you just need to write one for the NFD that you can plug in for the real code, for the plugin for the simulated code, and everything will be working with this respect. Another big component for the ndnSIM, or this shim layer, is a set of helpers. So those are actually essential ones to kind of facilitate creation of the scenarios and configuring the scenarios. So the basic one is this NDN stack helper that I will show you several times today later. And it's basically ensuring that the NDN stack is installed on the nodes. Or if you prefer talking about like in the real world environments, like installing NFD on the node. It's not exactly like that because it's kind of not installing the application, but rather it's in creating the instance of NFD and starting it on the node. So that instance now is ready to receive packets, process NDN packets, and do other stuff. We have, look, in order to facilitate the forwarding inside this simulation scenario, we have a global routing helper that can pre-calculate the routes and pre-establish some of the routes if that's your choice. You can directly deal with the FIB using FIB helper, basically registering specific routes on specific node to specific locations. For the strategy choice, if you're playing with the different strategies, you need to select stuff. For app helper is to basically to install a specific application, a specific traffic generator on the node. Link control helper is, so this one of the reasonably recent additions to define what kind of losses you want to have on the links in order to evaluate the properties of the application or the forwarding strategy, and a few others. One of the critical components for the ndnSIM are those tracers. So these are actually the place where you those components that necessary to actually get some useful results from the simulation, because simulation is simulation. There's no side effect of the simulation, because if you don't set up any metric collection facilities, you're basically just wasting resources. And how to collect some useful information from the simulation is using metric collectors that in terms of NS3 are called tracers. And we created the one that is NDN packet tracer. I will try to show later. There is a very basic content store tracer, just collecting what was satisfied, what was not satisfied. And we have also very basic application level tracer. Again, this only applies for the very basic application that's available in NS3. And this one is for kind of measuring delays of receiving data after interest has been expressed. But we'll probably talk a little bit more about the tracing and metric collections in a little bit later. We have several technical reports published about ndnSIM, describing a little bit more in detail the structure, but most of the information, and I would recommend if you haven't been yet on ndnSIM website, is there. So that would be the first place you want to go when you want to start dealing with ndnSIM or try to install it. And this is basically what I'm doing every time I'm trying to install ndnSIM on the new node, because there are some instructions there that directly allow you to just copy paste a few lines and you install in the application, installing dependencies and installing all necessary components and installing the ndnSIM. So basically it's a very basic website, but has a lot of information. So the introduction is basically what I just covered, like with a little bit of special details of different components, how things are linked together. So there are some parts of ndnSIM, some parts of ndnSIM core, and this is NDN protocol stack is effectively kind of wrapping out the instance of NFD inside of the ndnSIM inside of NS3 node, and then that instance is what is receiving all the packets given to NFD for the processing, and again receiving packets from NFD and kind of giving the packet further. Uplink servers and net device protocols, basically the ones that talk into the on one side for the applications, on the other side for the to different nodes. Either it's directly connected over point-to-point link or some other links, and we have been exploring various types of implementation, including Wi-Fi and some ad hoc communications as well. And the one that we're going to be dealing right now is getting started. You can install ndnSIM on a number of different platforms. It is possible to install ndnSIM on this platform, and it will work, and you can run the simulation scenarios, but I would actually recommend you do it on Linux. And for one, it's just a little bit easier to install, especially if you want to run this module called Visualizer to see, at least in the basic environments, what are the nodes inside the simulation environment and very basic traffic pattern. I actually no longer able to show you the live example of Visualizer on my platform, because of the dependencies. Like some Python packages no longer support it, or at least the Python switched to Python 3, and those packages no longer work. But on Linux, it's still working, so you can try that. But again, like if you're trying to install the applications on macOS, you have to use the homebrew and just copy paste these commands, and it will install necessary components. On Linux, depending on which one you're dealing with, you just copy paste these commands and you install all the necessary dependencies. For the Python binding, so this one is again, yet another feature of NS3 is that even though the NS3 itself is written in C++, it has the option to drive the simulation scenario using Python. And for this one, they kind of created a very interesting framework, automatically creating Python bindings by scanning C++ code and extracting public interfaces and creating equivalent code for C++ in Python. It has tons of limitations and may not work for all scenarios, but for some basic scenarios, it's actually working quite nicely. And if it does work for you, or you know that it's going to work for you, you can enable those things by installing a bunch of the Python modules in different ways on different platforms. It's in Ubuntu and macOS are slightly different. But again, you can copy paste and things will be working. So this one on macOS, I tried it recently, and it's unfortunately no longer fully works. The Python bindings themselves work, but the visualizer is not working. So that's kind of a little bit of a problem. But for the prerequisites, that would be basically it. So the only thing that you would need to do afterwards is to copy paste those commands. It's, as you can see, it's a little bit of complex downloading process because you have to download the base NS3. If you're using Python bindings, you have to download yet another repository, and finally download the ndnSIM repository into the correct place in that structure. It's just a little bit of a process. So in NS3 itself, they actually have an app called Bake that allows this automation. But again, I kind of decided to just provide these basic instructions because sometimes that Bake is not fully working. At least it didn't work as nicely just doing a straightforward, do it manually this way. And NS3 is just one repository, and it's basically it's the version of NS3, like one of the recent versions, plus any modifications, like a few small modifications that are necessary to actually run ndnSIM. We try to do it very minimal changes. I can just a little bit highlight them. Yes, sir. So this is kind of a few changes that exist on top of the recent version. And basically, most of the stuff is just extension module for the visualizer. A few things about the rescanning Python bindings with ndnSIM enabled, and a few small other things here and there. This one is a little bit complex repository. It's actually a repository containing links to two other repositories. So ndnSIM is the base version of all the shims in there. And it contains a specific version of NFD and specific version of ndnCXX. It has the same approach. They're taking the core code of the actual version of ndnCXX and applying a certain number of patches to make it work within ndnSIM environment. And the same thing for NFD. And if I just highlight a few things in there, so like how many changes are there? There are not that many changes, even like much less than changes for the base NS3. And it's mostly applying about the scheduler, about the logger, and about, again, the schedule of the hacking of NDN face, and a few other small things like extension, adding additional tags for ndnSIM. The whole reason I'm kind of highlighting this one is you have to have this specific flag recursive when you're cloning ndnSIM repository, because it needs to clone the base ndnSIM and the rest of the modules in there. And if there are some available updates available inside the ndnSIM, you would have to update them recursively. So you have to update the base ndnSIM, and you have to update ndnCXX and NFD inside of that folder structure in order everything to be picked up. But again, usually if you're just starting, you just copy these commands and everything will be working. After that is a long process of building this stuff. So in base model, you can just go to the NS3 folder, call it like WAF configure and WAF. And it will start building an NS3 with ndnSIM module. There are a few things that you can enable as part of the parameters. So you can enable examples, you can enable tests, like if you want to run ndnSIM or NS3 test frameworks. And you can also, which is highly recommended to do for running the actual simulation scenarios, is to compile in optimized mode. I will try to highlight this a little bit more again, but this is the most important part for NS3 or running NS3. When you configure it without specifying that you want to configure in optimized mode, it by default will do it in debug mode. And with the debug mode, it enables like excessive amount of logging and a lot of other things, like some debug routines that will slow down simulation significantly. And by significantly, I mean like it's 10 times slower usually to run it in debug mode versus optimized mode. So again, if your simulation is running too slow, make sure that you run it in optimized mode. And for that one, you just need to add a flag -d space optimized, and I'll show a few examples when I'm running. Disable Python, this is in case you have a problem with the Python, you can just disabling. And finally, to run the applications, run scenarios, you can just run this in this model.